So I need your attention up here, please. So this lesson, I already talked about what it's about. It's called the converse of the Pythagorean Theorem. So I'll explain what that means, but it's basically, yesterday we were told we had a right triangle, and so we knew we could use the Pythagorean Theorem, and this is using the Pythagorean Theorem to see if you have a right triangle, or to make a triangle, find a value of x that makes it a right triangle. So it's just kind of going in the reverse order. You don't know for sure at the beginning if you have a right triangle. So converse in general, what that means is, say you know, like normally when you get an addition problem, you have like 6 plus 5, and you would give the answer as 11. The converse would be being given the 11, given the answer, and saying that is equal to 6 plus 5. So it's kind of switching around your hypothesis and your conclusion, if you think of it that way. So converse of Pythagorean theorem, like I said, guys, converse of Pythagorean theorem, yesterday we said if you have a right triangle, then a squared plus b squared equals c squared. We're switching that. We're saying if a squared plus b squared equals c squared, then you have a right triangle, where c has to be the longest side. So we're just switching around our thinking, or our hypothesis conclusion. Then you will see today you do not always have a right triangle. A squared plus b squared may not always equal c squared. So we can use the sides of a triangle and a relationship that has to do with Pythagorean theorem to classify a triangle as acute, obtuse, or right. So in a right triangle, this is the Pythagorean theorem. C squared will always equal a squared plus b squared, where again, for all three of these, C is the longest side, if you wanted to fill that in right away. And you'll see how this is used in examples, but if C squared is equal to a squared plus b squared, then you know you have a right triangle. Say it's not equal. Say C squared is, this is less than, just so you don't get those confused. Between less than and greater than, I always tell students this, it might seem silly, but if you make them on your hands, less than is on your left hand. Less than's on the left. So that way when you see the symbol, you know, less than, greater than. So if C squared is less than, smaller than, a squared plus b squared, then you have what's called an acute triangle. So an acute triangle is where all three of your angles are acute. What does acute mean? Less than 90. So all three angles are acute in an acute triangle. And then if your C squared is greater than, so larger than a squared plus b squared, again, C is the longest side, then you have an obtuse triangle. An obtuse triangle has one obtuse angle. So right triangle has one right angle, an acute triangle, all three angles are acute, and then obtuse triangle, one of the angles is obtuse. And obtuse means what? Larger than 90, but smaller than 180, yes. So here's how we use it. If it says classify each triangle as acute, right, or obtuse, and I do have here to show work. So thinking ahead to an assessment, which your next quiz, your quiz on this is next week Friday, so a week from tomorrow. But I expect to see work. If you just have acute, right, or obtuse written down and there's no work, even if you're right, you're correct, I don't know if it was just a complete guess. So I need to see work that justifies why you're saying it's acute, right, or obtuse. So what you want to do is look at the 3 sides you're given, pick out which one is the longest, because that is your C. So in this case, 16, that is my C. It doesn't matter between the other 2 which one is A and B. So I'm just going to call the 7A and the 14B. And then I have to figure out what the relationship between C squared and A squared plus B squared is. Is it equal? Is it less than? Is it greater than? So I'm always going to put the C squared on the left side. So I'll do 16 squared. I'm not going to put like a symbol here. I'm trying to figure out what the relationship is. And then over here I have A squared plus B squared. So 7 squared plus 14 squared. And then I figure out what both of these are. Anyone have what 16 squared is? 256. And then what about, well, 7 squared plus 14 squared? Yeah, this is 49 plus, okay, so the final thing is 245. This I think is 196. So 245. So we have 256 and 245. 256 is larger, so greater than 245. So since C squared is greater than A squared plus B squared, we then have an obtuse triangle. I'm just going to draw an arrow, that's why. What was that? So, which part? So because I calculated C squared and then A squared plus B squared, C squared is larger than A squared plus B squared. And if C squared is greater than, then it's an obtuse triangle. So you're figuring out the relationship between these 2 numbers. All right, so let's look at another one. Number 2, 41, 40, and 9. So which one is C? 41, because that's one that matters the most. The other ones, which one is A and B, doesn't really matter. So I would have 41 squared, and then 40 squared plus 9 squared. Anyone have 41 squared? And then 40 squared plus 9 squared. Okay, exact same number. They're equal. So what type of triangle is this? A right triangle. Because that Pythagorean theorem, or that is the Pythagorean theorem. C squared is equal to A squared plus B squared. Okay, and then I included in 3 and 4, just because the numbers are written in exact form, they're written as radicals, I want to make sure that you would use these numbers within this problem correctly. So when looking at these, so square root of 5, square root of 12, square root of 13, do not change them to decimals, but which one of those is the largest? Yep, so the square root of 13 is your C, and then I'll just call this A and B. So I would have, for C squared, the square root of 13 squared, and then square root of 5 squared plus square root of 12 squared. Anyone know without typing it in a calculator, what's the square root of 13 squared? It's just 13. So square and a square root, those are like addition and subtraction. They're inverses. They cancel each other out. So when you square a square root, this is just 13. Meaning this square root of 5 squared is just 5. Square root of 12 squared is just 12. So you get 13, and then 5 plus 12 is 17. 13 is less than 17. So this is what type of triangle? Acute. 4 is a little different yet, just because you don't just have the square root, you have a value in front of the square root also. You might need to type them in a calculator to figure out which one is the largest. Did anybody figure out which one of these 3 is the largest? So don't like write down and change them to decimals, but you might need to type them in to see which one is the largest. The 4 square root 4 is the biggest. Okay, so like I said, if you want to make a note to yourself, it's okay to type them in a calculator to see which one is the biggest first, but don't change them to a decimal. And then I'm just going to call the first one A, the last one B. Okay, so I have 4 square root 4 squared, and that is a quantity squared. And then I have 2 square root 3 quantity squared plus 3 square root 5 quantity squared. So when you square this, it's kind of like in the problem I had you work on while I checked the assignment, when you had 2x quantity squared, that is 2x multiplied by itself, but you can give that exponent of 2 to both the 2 and the x, so it was 2 squared, which was 4, and then you still had the x squared. So this means I am distributing this to both. So I have 4, this 4 out front, 4 squared, which is 16, multiplied by the square root of 4 squared, which for this one, the square root and square cancel, and that's just 4. So this one is 16 times 4, so that's 64. Okay, so over here, if I distribute this, this is 2 squared, which is 4, times the square root of 3 squared, which is 3, so that's 12, plus, and then 3 square root 5 squared is 3 squared, which is 9, times square root of 5 squared, which is 5, that's 45. And then I just need 12 plus 45 is 57. Okay, so I have 64 is my c squared, a squared and b squared together are 57. 64 is larger. So what type of triangle? Obtuse. Okay, so questions on those? Okay, now on the other side, I'm going to skip over a couple of these just to leave you some more time for your assignment, because the warm-up, we took some time for that. So 5, this was just an extra practice problem like you saw yesterday. You already have the right triangle. 6 is asking, is it a right triangle? So it's kind of like the ones we just did on the front. You're determining if this would be a right triangle. But I do want to look at 7. And then 8, we might actually come back to this and discuss this a different time, because it's a good problem, but again, I want to leave you time for your assignment. 7, though, this is mainly for me to help you review some algebra. So we have a right triangle. We already know it's a right triangle, and it says find the value of x. So how would we do that? If you already know you have a right triangle, what would you do to find x, Melcher? So 9 squared, what was the next part? That'd be squared, yep. So which one of these sides is your hypotenuse? x. This is the hypotenuse. Yep, so these should be added, and then this would equal just x squared. So notice how I wrote the x minus 3. That is a quantity, so it's the quantity squared. So now when you're simplifying this to solve for x, 9 squared is 81, plus, not to confuse you, on the front, I said when you have something like this, 2x squared, you can distribute the exponent because the 2 and the x are being multiplied. The x and the 3 here are being subtracted. You cannot distribute that exponent. So this really means, just like 2x quantity squared, this means 2x times 2x. This means x minus 3 times x minus 3. And then this is just x squared. How do I multiply these? FOIL. Distributive property, but the mnemonic device is FOIL. So I have 81 plus, if I use FOIL for this, so I have my first terms, x times x is x squared. X times a negative 3 is minus 3x. Then another negative 3 times x minus 3x. Negative 3 times negative 3 is a positive 9. And I still have x squared on this side. I can clean up my left side a little bit. I have some like terms, so I can combine the 81 and the 9. So that's 90. I still have the x squared, and then I can combine the negative 3x's. They don't cancel out. That's negative 6x. And I have x squared over here. Okay, what do you think you do as a next step? I'm trying to solve for x, okay? Okay, and notice cancels out on both sides. So I have 90 minus 6x equals, now I have 0 over here. So now what do I have to do? Add the 6x, yep. I'll continue up here, so 90 is equal to 6x. Then I can divide by 6. And 90 divided by 6 is 15. And it did just say find the value of x. X is 15. Okay, so that was just reviewing whenever you have a quantity like that squared using FOIL, not distributing the exponent. Now, there's a lot of rules in algebra when you can do things when you can't.